Friends, very good morning to everyone. Today's let us discuss with organic chemistry, the basics and reaction mechanism. What is organic chemistry? Organic chemistry is a separate branch of chemistry which deals with carbons. The chemistry of carbon compounds is organic chemistry. Why this separate branch for single carbon compounds? Because the carbons are highly versatile in nature. The carbon can have bonding with heteroatoms like oxygen, nitrogen, sulfur, halogen, hydrogen, and along with its own species carbons. And also it binds or bonds with metals like magnesium, lithium, potassium, sodium, and whatnot. Carbon can bind with phosphorus. And what makes it so versatile? These carbons are considered like Indian people. India is a country which has unity in diversity. We have 22 states which starts from Marathis to Telugulians to Kannadigas to Tamilians to Malayalis to whatnot. The Malayalis work in North India and North Indian works in South India. Marathis work in Karnataka, Karnataka people work in Maharashtra, and so on and so forth. And all the Indians not only work in parts of India but all parts of the world, starting from European countries to your Asian countries to Arabian countries too, Australian country too, and where all the men are there, where all men are possible to work, Indians are seen. Indians are highly versatile species of this whole world. Likewise, the carbon is also. What is its reason for its versatility? The more versatile you are, the more successful we are. Carbon is the most versatile species which a chemist has seen. Let us look into what makes it so versatile. It bonds with each and everything and each and anything. The reason behind it is the nucleophiles and the electrophiles. Today's subject of discussion is this electrophiles and nucleophiles. The basics of chemistry lies in the following statement. Unlike charges attract each other, like charges repel each other. It is something similar to like poles repel each other, unlike poles attract each other. Where this charges comes from? Let us look into it. In reaction, where the bonding occurs between the two different species or within the same species, and the electrons which are rich will give those electrons to the electron deficient species and the bonding occurs. The electron rich species, what we see in the compound or in the molecules, is called as nucleophile. Nucleus, nucleo means nucleus, Felix means love. Nucleus loving species. Nucleus is made up of protons and neutrons, and that's why because of these protons it is positively charged. These nucleophiles are positive charge loving species. Nucleophile are electron rich, that's why they love electron deficient species. Positive means deficient. We know that we love what we don't have. Recently, in an interview, a cine actors who has star value was talking about that he want to move in India with metro lines, with metro trains, but he is not able to because of security issues. So rich, they need not have to move with the metro trains. But still, they love that. Why is it so? They are nucleophiles. The rich stars are nucleophiles. The rich stars are the examples of nucleophiles. Electron deficient species is an electrophile. The name indicates electrophile. Electro represents electron. Philic means loving. Electron loving species. Why it is electron loving species? It's because it is electron deficient in nature. Electrons are negatively charged, and that's why as it is electron deficient, electrophiles loves negatively charged species. This is negative charge loving species. Again, it indicates we love what we don't have. We as a common man, we would like to fly in the flights. We would like to have our own choppers. Whereas the stars who have choppers want to move with the local trains. This is what the life is. The reaction between this nucleophile and electrophile, the attraction between the electrophiles and nucleophiles is the basis of reaction. Unlike poles attract each other, like poles repel each other. This is the basis of nature, and the electrophiles and nucleophiles attraction is the basis of chemistry. Now we can relate the nature's phenomena with the interaction of the electrophiles and the nucleophiles to form the new bonds. Nucleophiles as a whole are electron rich species which are capable of donating the pair of electrons. Nucleophiles can be classified into three types. The first type are the species having non-bonding pair of electrons or pair of electrons. CH3, CH2, NH2, ethylamine. The nitrogen here is in hybrid state which has lone pair of electrons. The hybridization and the lone pair of electrons, how it arises, will be dealt in future. This amino group in hybrid state in ethylamine has lone set of lone pair of electrons, and this excess electrons which it has, it donates that electrons. It is capable of donating these electrons to others. And this donating capability of this lone pair of electrons is the basis for formation of new bonding. CH3, CH2OH, ethanol has oxygen which is in hybrid state with has also lone pair of electrons in it. The thioethanol CH3, CH2SH, the oxygen is replaced by sulfur here. This is also electron rich species like that of oxygen and nitrogen. These are one setup of nucleophiles which has lone pair of electrons. The first set of nucleophiles are compounds with non-bonding pair of electrons or lone pair of electrons. The second set of nucleophiles are electron-rich terminus of highly polarized species. These compounds which are having polarized bonds. How these polarized bonds are formed will be discussed in future. When the carbon is combined with the magnesium, metals like magnesium or lithium, magnesium is more electron richer than carbon. This donates the electrons to the carbon and it makes it electron rich. That's why the carbon combined with magnesium is electron rich, which is represented as delta minus. The methyl lithium, the carbon is bonded with lithium. Lithium, a metallic compound, is more electron rich or more electropositive than that of carbon. It donates the electrons, making the carbon electron rich. This is a polarized molecule, and the electron rich terminus is carbon, and electron, as these electrons are donated from lithium, it becomes electron rich. The electron rich terminus of highly polarized species containing the polarized bond are the next set of nucleophiles. The molecules having atoms which are combined with sigma bonds or pi bonds or another set of nucleophiles. For example, an alkene like ethene, in the presence of an electrophile H plus, this is an electrophile. In the presence of an electrophile, the pi electrons at the multiple bonds moves towards one carbon owing to the electropositivity of the hydrogen, and once this electrons moves, the carbon here becomes electron rich and that combines with H plus. Once this combines, it forms CH3 and CH2 plus. The compounds with multiple bonds, that sigma or pi bonds, which are reasonably stable with less than full shell of electrons like carbocation or trivalent boron, are another set of nucleophiles. There are three types of nucleophiles. The nucleophiles are the species having lone pair of electrons are the first set of nucleophiles. The polarized molecules with polarized bonds with electron rich terminus are another set of nucleophiles, or the molecules with multiple bonds are another set of nucleophiles. There are three types of nucleophiles which we find. Like borane, it combines with H plus. The excess electrons are here, H minus combines with H plus, and it gives rise to BH3. This is having the sigma bond. Here it is the in alkene, it is having the pi bond. Sigma and pi bonds attached to atoms which are reasonably stable with less than full shell of electrons like carbocations or trivalent boron are the nucleophiles. Nucleophiles are capable of donating the lone pair of electrons to electron deficient species like electrophile, and this donating power of nucleophile to electron deficient species like electrophile is the basis of bond formation between the two different species. Then what are electrophiles? Electrophiles, as we have seen, they are electron deficient species capable of accepting the pair of electrons. It is exactly opposite to that of nucleophiles. Nucleophiles are electron-rich species capable of donating the pair of electrons, whereas electrophiles are electron-deficient species which are capable of accepting the pair of electrons. Electrophiles can also be classified in the similar fashion as that of nucleophiles into three types. The first set of nucleophiles are having a set of lone pair of electrons. Here these are atoms bearing less than full shell of electrons. Like H plus is an electrophile, CH3 plus is an electrophile. CH2 double bond CH2 alkene, in the presence of H plus, it donated its lone pi electrons to the hydrogen and it created a CH3 plus. The CH3 plus is a electrophile. Electron deficient terminus of a highly polarized bond, which is denoted as delta plus. The carbon is bonded with oxygen. Oxygen and carbon bonding is not equal sharing of electrons. That's why carbon gains lesser amount of electrons, whereas oxygen has higher amount of electrons. It is a polarized bond between two atoms which are having different electronegativities. Because of this, one gains the electron deficiency, another will be electron rich. This electron deficient terminus of the polarized bond is an electrophile. Or C triple bond N. The carbon is bonded with nitrogen. Nitrogen is electronegative and it pulls the electrons towards itself. And the carbon and nitrogen bonding, the electrons are not equally shared. That's why nitrogen becomes electron rich terminus and the carbon becomes electron deficient terminus. Electron deficient terminus of a highly polarized molecule is an electrophile. The N minus, which is having delta minus, electron rich terminus of the polarized bond is a nucleophile. Nucleophile and electrophile exist hand in hand. The atoms bonded to groups that may becomes weak bases after accepting a lone pair of electrons are another example of electrophiles, where this bonded to these groups becomes weak bases after accepting a electron pair. They are good living groups like Cl minus, Br minus, I minus, F minus. The CH3Cl, the chlorine is electronegative, that's why it is electron rich and it pulls the electrons towards itself, making it electron rich, and that's why carbon becomes electron deficient, which is represented by delta plus. It can dissociate by taking the lone pair of electrons and making this electron deficient, and electrophile is there. The first setup of electrophiles are atoms bearing less than full shell of electrons like H plus, CH3 plus. CH4 has full shell of electron. One hydrogen along with its electron pair, if it leaves, it gives rise to electrophile. The electron deficient terminus of highly polarized molecule is second set. Another third set is the atoms bonded to groups that becomes weak bases after accepting the lone pair of electrons. It accepts the lone pair, pair of electrons, and it loses as Cl minus, which are weak bases, and it gives rise to an electron deficient species, that is electrophile. Electrophile are species which are capable of accepting the pair of electrons from electron rich species. The nucleophile reacts with an electrophile to form a new bond. And this bond formation of between the electron rich species and electron deficient species is the basis of bond formation, and it is the requirement or the basis for the versatility of carbon. Nucleophilicity or electrophilicity is the term which is used to refer to a species which can donate or accept the pair of electrons. The higher the nucleophilicity, higher the donating capacity, or lesser the nucleophilicity, lesser the donating capacity, and vice versa. To how much extent the species can donate or accept the pair of electrons is represented as nucleophilicity and electrophilicity of the particular nucleophile or an electrophile. These nucleophiles are electron-rich species. What are bases? As per Lewis acid base theory, bases are electron donors. all nucleophiles and bases. Bases are also electron donors. Nucleophile also are electron donors. Are nucleophiles and bases similar? It is said that all nucleophiles are not bases, but all Lewis bases are nucleophiles. Similarly, all electrophiles are not acids, but all Lewis acids are electrophiles. It is something like all Muslims are not terrorists, but all terrorists are Muslims. The vast majority of the reaction that we will see in the organic compounds is because of the reaction between the electrophile and the nucleophile. And this reaction depends upon the nucleophilicity and the electrophilicity of the species. And how these bonds are formed. What are the types of bonds formed? How these bonds are formed and when it is formed and how it is formed will be the subject of discussion for the coming presentations. Till then, have a nice day. Thank you.